This is VA3 Sugar Zulu.
I got Whiskey 4, Golf, Lima, November. W4GLF.
On 20 meters.
Thank you for the call. We are copying 5 by 7. Signal report for you to this morning, 57.
I struggled a little bit with the low pass filter for 20. You could see.
London, Ontario, Kendo Zan, Zulu, Echo, November. So back to you, my friend. How copy?
Can't hear the other station just as well. Turn around here.
Whiskey Delta 4, November Golf, Bravo. Calling CQDX and standing by.
I think it sounds really good. And, you know, the thing is, I never built the RF amplifier. So you see, the antenna comes in, goes to the 20-meter low-pass filter, and goes right to the ADE1 mixer. From there, 5.2 megahertz goes through the filter, TIA filter, TIA, product detector, the audio amplifier.
Whiskey Delta 4, November Golf, Bravo. Calling CQDX and standing by.
You know, with the low pass filters, I used LC, the LC program. The LC program worked out fine for the 75 meter filter, and I just built it according to their specs. And then I tested it with the Arduino. No, I tested it with the Nano VNA. And I also just did old school testing. I put a 50 ohm load off one end, ran the signal from the HP signal generator in, and watched the output with the Rigel scope. And it looked great. It looked fine. It was right where it's supposed to be. When I did the same thing on 20 meters, a couple weird things happened. One, when looking for, or when I specified I needed a 50 ohm impedance through the thing, it would give me some really ridiculously low values for the coils, like 0.02 microhenries, which is hard to wind. It's like 1 or 2 turns. So I went ahead then and specified that I wanted to use 1 microhenry coils, and then the LC program allowed me to do that, but then it specified a little matching network. So this little transistor here, about 30 picofarads on either end, matches the resulting, I think, 700 ohms to 50 ohms. So it's 50 ohms at both ends. And that was fine. But then when I fired it up, I did my standard test using, like I said, the signal generator and the scope. But I found that the filter, the passband looked good, but it was quite low. It was down around 12 and 13 megahertz instead of up in the 13, 14, 15 megahertz range that I needed to get 20 meters. So what I did is I just pulled some turns off each of the coils. I left the caps the way they were supposed to be, pulled the turns off the coils, and got it so that it was passing the 20 meter band. And then I looked at it in the Nano VNA, and it looked really good. I actually tweaked the resonant frequency a little bit by scrunching the turns on the toroids or opening them up a little bit, and I got it to just where I wanted it. So it looks pretty good. But it was a bit of a struggle to get the bandpass filter tuned. I had never really done that before, and I think it's important. This whole thing really makes me think also that, it makes me rethink the fact that I have an RF amplifier in my 40-meter Digitia. I might not need one. I know that Farhan, when he went to the MicroBitX, dispensed with the RF amplifier ahead of the mixer, I believe, and just went from antenna, low-pass filter, mixer, and then the IF amplifiers at the IF at the IF frequency prior to and after the crystal filter. So that is really interesting, and it goes along with the words of wisdom from the receiver gurus who say that you shouldn't put a whole lot of or any amplification ahead of the mixer, especially if you're using a diode ring like we are here with the ADE1. Anyway,
Whiskey Delta 4, November Golf Bravo, beaming Asia. CQ, CQDX, CQ, CQ, CQDX, beaming Asia. WD4NGB, Whiskey Delta 4, November Golf Bravo, calling CQDX and standing by.
hope he gets somebody. Let's go down to the CW portion of the band. There's the digi signals. I think that's like 14075. Maybe that's it. VE3FP. Pretty cool, I think. Anyway, so now we got 20 meters and 75 going, and it's already proving, although it didn't need to be proved, it was proven by the arithmetic. But this is the Mythbuster scenario. So on 75, I have a lower sideband signal coming in here, but when the lower sideband signal interacts with the 9 megahertz signal from the VFO, the signal with the modulation, the 3.885 megahertz signal, for example, is subtracted from the VFO signal so that we can get to the 5.2 megahertz IF frequency. So that means that on 75, there is a sideband inversion, which is a good thing because the filter, the crystal filter, as I pointed out, is basically an upper sideband filter, which means that the carrier oscillator is located on the lower end of the passband. So really to hear 75 meter signals, we need that sideband inversion. So by the time the 75 meter signal gets to the crystal filter, it is in fact an upper sideband signal because it has gone through sideband inversion in the ADE1. Okay, so then boom, it goes through, and then we have the BFO and the BFO right here, which will also be the carrier oscillator when it's transmitting, crystal controlled, but we don't change it at all. It stays the same place at all times. We don't have to switch that around. We don't need two crystals, or we don't need to switch it. This is actually a good thing because one of the things I was reminded of here was when you've got the IF at 5 megahertz, that's pretty low. It is more difficult to move the frequency of your crystal. So I used the lowest frequency crystal of the batch that I had, but I still needed to move it a little bit, and so that's why it's kind of in VXO configuration. This coil is a trifiller toroid left with me by Farhan, and it and a little trimmer cap allows me to move this thing down just a little bit, just to the spot that I need it, so that it'll interact with the crystal filter in a kind of USB mode. It'll be the crystal, the BFO frequency will be at the lower edge of the passband of the crystal filter. So there we have 75 meters comes through, boom, and I'm able to listen to it no problem. But on 20 meters, USB, a USB signal comes in. So this signal, say at 14.2, and then what we do here is we subtract from 14.2 the 9 megahertz energy here. Here we're subtracting the frequency of the VFO from the signal that is having the modulation. So this is the signal that's being subtracted away from this signal. And in that case, no sideband inversion. So the USB signal comes in, it remains a USB signal and happily passes through the crystal filter and is happily detected here in the product detector using the same crystal oscillator that I described before. Anyway, so I guess the thing to do now is I want to work a little bit more on these bandpass filters because I'm not entirely happy with the way they turned out. I want to look into that a little bit more, figure out why many of the programs were giving me values for the filter that looked great, but when I built them, they were low. So maybe I'm doing something wrong here. But we'll take a look at that. It may have to do with my Manhattan board technique. I may be adding some capacitance that with my little pads that I shouldn't be adding. We'll have to take a look at that. And then I guess, yeah, I should build the transmitter circuitry, but I'm going to have to order some parts. I'm running out of some bits and pieces that I need to get this thing going. But I've got plenty of space, and because I've used mostly TIA amps, it's a relatively simple process just to reverse the signal flow, add a little microphone amplifier over here. This becomes not the product detector, but the balanced modulator. TIAs and the filter work in reverse. And then over here, I'll just need some RF amplification and some switching to move the DC voltages around. And then we'll be in business, and this thing will be a transceiver. Anyway, that's it for now, and stay tuned for more Mythbuster rig news here from Solder Smoke 7.3.